Today we are learning one of the most feared topics in functions, range. And trust me, most students are solving it completely wrong. Students know how to find domain, but when range appears in exams, panic starts. So let's try to find the range of the following given functions. The common mistake most of the students do while finding the range for the given function is that they just start substituting the random x values in the function and guess the range. But this strategy will not work in competitive exams. It completely fails. So the domain means all allowed x values and range means possible y values. So range means what values can the function actually produce. There is the core four-step method to find the range of any given function. First, set function to y. Second, solve the equation for x. Then, identify restrictions on y. And in the last, write the range. And if you master these 4 steps, range becomes very easy. Here is the first question. Find range of f of x equals to x squared minus 6x plus 13. Pause the video and try to find it yourself. Whenever you see a quadratic function, try converting it into square form. Here, we complete the square and rewrite the function as x minus 3 whole square plus 4. Now, the function becomes much easier to analyze. A square can never be negative, so x minus 3 whole square is always greater than or equal to 0. That means smallest value of the function is 4. And after that, function keeps increasing forever. So the range is from 4 to infinity. Next question, find range of f of x equals to x minus 1 upon x plus 2. This question looks simple, but many students make mistakes here because they try to guess the range instead of solving logically. To find the range, we first replace the function with y. Now our goal is simple. Write x completely in terms of y. Now multiply both the sides by x plus 2 to remove the denominator. This makes the equation easier to work with. Next, move all terms containing x to one side. We are preparing to isolate x. Now take x common. This gives us x only once, which makes solving easier. Finally, divide by y minus 1 on both sides. Now x is completely written in terms of y. Here, denominator can never be 0, so y cannot be equal to 1. That means function can get close to 1 but never actually reach it. So, every real value is possible except 1. Therefore, the range is all real numbers except 1. Let's try to understand this function visually with the help of the graph. At x equals negative 2, the function becomes undefined. So we get vertical asymptote at x equals to minus 2. And as x becomes extremely large, the graph gets closer and closer to y equals 1. But it never touches it. That is why 1 is excluded from the range. Here is the important idea. Always remember, vertical asymptotes usually appear where the denominator becomes 0, and horizontal asymptotes describe what happens as x moves toward infinity. So you can easily find horizontal asymptote from the end behavior of the graph. Quick challenge for you. Can domain and range be equal? Comment your answer before the video ends. Look at this. This question looks tricky. Find the range of f of x equals to under root 9 minus x squared. Most students think that here domain and range are equal, but this thinking is not correct. First, look inside the square root. The expression inside the root must always stay greater than or equal to 0. So we write 9 minus x squared greater than or equal to 0. That gives x squared less than or equal to 9. So x lies between minus 3 and 3. Now notice something important. A square root can never give a negative value. So the maximum value of function happens when x is equal to 0 and the maximum of the function is equal to 3. And minimum of the function happens when x is equal to 3 and the minimum value of the function is 0. Therefore, range of this function is from 0 to 3. This is a very important range question and many students get confused because of the fraction. Find the range of f of x equals to x plus 1 upon x. First, replace the function with y. Now multiply on both the sides by x to remove the fraction. Then rearrange the equation. Notice carefully, this becomes a quadratic equation in x. For real solutions, the discriminant must be greater than or equal to 0. Solving the inequalities gives y square greater than or equal to 4. So y is either less than or equal to minus 2 or greater than or equal to 2. So the function can never take values between minus 2 and 2. Therefore, the final range is minus infinity to minus 2, union of 2 to infinity. Let's quickly summarize the most important methods to find the range. For quadratic functions, use complete square. For visual functions, use graphs. For rational functions, solve the equation for x. And for advanced questions, use discriminant method. And always make sure real solutions exist. These 5 ideas can solve most range questions in exams. If you solved today's last challenge, you are already ahead of most students. Now try this final question and comment your answer. And if this video changed how you see range, subscribe now for more such videos.